What's going on, everyone? Welcome back. Patrick here. Moving on to the next trig limit. So we got the limit as x approaches 0 of sine x cubed over x squared. So this is a pretty unique one. We haven't done one like this. We've already done a bunch before, came up with some of these results. So make sure you're watching these in order. If you didn't watch the previous examples, make sure you do before watching this one. So we got the limit as x approaches 0 of sine x cubed over x squared. Now, as we've been doing in the previous examples, what we want to try to do is have whatever expression is here also be in the denominator. Because if that happens, as long as that expression is going towards 0 as x goes towards 0, we could do a change of variable and change it to this here. But notice that x cubed and x squared are different. So we can't use this yet. So how can we make the denominator be the same expression as this x cubed here? Well, we can multiply the denominator by x, because x squared times x would give us x cubed, that same expression here in the brackets. However, we can't just randomly multiply an x inside the denominator. We also have to multiply the numerator by an x, right? Whatever we multiply the numerator or denominator by, we've got to multiply the opposite by it as well. So it's like we're multiplying this expression by 1, which keeps it the same. It's just we're adding more onto it. So now what's going to happen is when we do this, notice how we'll have sine of x cubed over x times x squared is x cubed, but we still have this x remaining. So I'm actually going to keep that x separate like that. It's like x over 1, which we don't have to write the over 1. We could just keep the x there. And now what I'm going to do is I'm going to use limit laws. Notice how we're taking a function, multiplying it by another function. So we can take this overall limit and split it up into two separate limits that would be multiplying by each other, like that. And now notice this here, this limit, if we rewrite up here, we got sine x cubed over x cubed. Notice that we could do a change of variable because we could say theta is equal to x cubed. And notice that if theta is equal to x cubed, as x approaches 0, what's the theta approaching? The theta is going to be approaching 0 as well, because 0 to the power of 3 is 0. So we could plug in theta for this x cubed, and then for this x approaching 0, we could plug in theta approaching 0. So we'd have the limit as theta approaches 0 of sine of theta all over theta, like that. Okay, so we know that this is that, just ends up equaling 1. So we know this first bracket is equal to 1. Going from here to here is this work right there. And then what's the limit as x approaches 0 of x? Well, if you remember from limit laws, if we have the limit as x approaches a of just x, that's always just going to equal to the a value. We could do a direct substitution. So the limit as x approaches 0 of x using this bracket is just going to equal 0. It's going to equal that a value right there. And then 1 times 0 is just 0. And so this ends up being the answer for this limit here. The limit as x approaches 0 of sine x cubed over x squared.